In this video, I want to discuss the final way for finding the area of a triangle and do a bearing problem that involves the law of cosines. So the final way of finding the area of a triangle is using something called Heron's formula. And for the intent of this course, I am going to just attach a link to a proof of Heron's formula in the description below. And you can check that out on your own time. But it's really not super critical for us to be able to know the proof in order for us to find areas of triangles using this formula. So all it is simply the square root of S. And what S is the semi-perimeter, or the perimeter divided by 2, half the perimeter. It's the square root of S times the difference of S and all of the side lengths. So if we were given a problem where we're given 3 side lengths, it's an SSS case. Notice we have an SSS case. We can first find the semi-perimeter by adding up the 3 sides, 5 plus 9 plus 8, and then dividing it by 2. And so S here is going to be, that's 14 plus 8, that's 22, divided by 2, that's 11. So S is 11 here. Now the area then of this triangle would be the square root of S, which is 11, times the difference of that side length minus and the others, all 3 sides. So 11 minus the first side, which is 5, 11 minus 9, which is that second side, and 11 minus 8, which is that final side. I went a little crazy with that radical sign there, but it's okay. And then from there, it's just the square root of 11 times 6 times 2 times 3, and you would get approximately 19.900 feet once you put that into your calculator. So that's all there is to finding the area of a triangle using Heron's formula. It is fantastic for SSS cases. So let's just recap the formulas that we know for finding the area of a triangle. The standard one is 1/2 base times height. This is great when we actually know what the height is. So I'll write that when we know the height. And then we have Heron's formula that we just discussed, and this is great for an SSS case, which is just S times S minus A times S minus B times S minus C. This is for an SSS case when we know all 3 sides. And we have 1/2 BC sine A, or the other variations, and you can just check the previous video for this, or I should say the video from 6.1 part 3. This is fantastic when we have an SAS case. And if it's another situation like an angle, side angle, or side angle, then often we just need to solve for another side first before using one of these 3 formulas. Now, I want to close this by actually doing a problem that involves a bearing and using the law of cosines to solve what we need to find. So we have a ship that travels 40 miles due east and then changes direction to northeast. Notice that because it's a ship, we're not using air navigation. We just want to use the standard bearings that we're used to in this course. So I'm going to go ahead and draw the ship here at this point. This is just kind of arbitrary. Just label this as point A. It traveled 40 miles due east, means directly east. So it traveled 40 miles due east. So I'll just go ahead and label that as 40 miles. And then it changes directions to northeast. So let me just change that color there. So from here, it changes directions to northeast. And we don't know exactly what bearing it took, when it doesn't say at least, but it said that once the ship traveled at this new bearing, so let's say that when the ship has traveled 30 miles at this new bearing, so even though we don't know the angle exactly, we know that its bearing is going to look something like this. And let me just see if I can move that over so it looks a little bit better. We know that it traveled 30 miles at this bearing. 30 miles at this bearing. It is now 56 miles from its port, the port being the place where it first started off. So this distance here is 56 miles. Okay, so the problem is asking us to describe the bearing the ship took when it changed direction. So what we need to find is this particular bearing here. What was the bearing it took when it changed directions from uh, this point? And so let me continue just labeling all of these points. So we're going to call this point B, call this point up here C. It'll help us keep track of all the angles that we're about to find. What we're first tasked in finding is this red angle here, because that's going to describe the bearing that we took to get from point B to point C when we changed directions. Well, first off, ask yourself, what type of case do we have? And what we're given are three sides. This is an SSS case, which means we would want to use the law of cosine. Well, we have a choice of which angle we want to find, but since we want to find this red angle here, it would make sense that we want to start by finding angle B. So let's use the law of cosines to find angle B. We would say the cosine of angle B is equal to 30 squared plus 40 squared minus 56 squared all over 2 times 30 times 40. So doing that, and I'm not going to show you all the calculations here, but angle B is going to be the arc cosine or inverse cosine of that entire quantity, which comes out to approximately 105.37 degrees. Okay. Now, I'm not boxing that because that's not my answer. That's not my bearing. That represents the entire angle B. And since we're trying to find that red angle here, note that this angle is a right angle here. That's a right angle. So to figure out the bearing, we would simply say 105.37 degrees minus 90, minus the 90-degree angle, we get 15.37 degrees. So the bearing is approximately the following: north 15.37 degrees due east. That would be the bearing that the ship took when it changed directions. Okay, so that gives me this angle there. All right. There's a second part to this question. They're now asking also, what bearing would the ship need to take to return to port? So let's do this in blue so we can see here. So in other words, if this ship now wants to return to port, we want to know what is the bearing that it needs to take. In other words, we would need to find this angle here. I'm not sure if you can see it that well, but it's the angle from the south vertical going back to point A. So that angle that I have in blue there, that represents the bearing. Well, at first this might seem a little unwieldy, but there are a couple things that we can actually do here. It would probably make sense to use law of cosines to find angle C. Because I know that if I find angle C, at least we'll find part of that bearing. And maybe I can use some geometry to figure out the remaining part. So let's go ahead and do that. So we're going to say the cosine of angle C is equal to 30 squared plus 56 squared minus 40 squared all over 2 times 30 times 56. And again, using inverse trig functions, I'm going to say angle C is approximately 43.53 degrees. I'm not boxing it because that's not my bearing, but I'm probably going to use this. So now that I know, going back to my diagram, now that I know that this part, and you know what, let me actually change colors here so we don't get too confused. Let me make this green and switch this over to green. Now we have just figured out this angle here. This angle here that I'm highlighting in green is approximately 43.53 degrees. The question then is, how can I figure out this remaining part that I need for my bearing? And take a close look and see if you can figure it out. Well, we've got alternate interior angles. We have parallel lines cut by a transversal here. We know that this angle down here is congruent to this angle. So again, this angle here is congruent to this angle here. And we figured that out earlier. We said that that was 15.37 degrees. So what we're going to want to do is go ahead and do 15.37 degrees plus the green angle that we found. So we'll say this. So I'm going to highlight this in red actually to indicate that these are congruent angles. So 15.37 degrees, which represented this angle here, plus the angle C that we found should give me all of this entire angle, which is our bearing. So we would just write 15.37 plus this angle C that we just found. And that would give me approximately 58.9 degrees. So then how would we write this as a bearing? Let me just change that color. Let's go switch back to black. How would we find that bearing? We would then say the bearing would be south, write this in black, south 58.9 degrees due west. That would be the bearing that the ship would need to take to return to port. And normally we'd want to write this in a sentence so it's clear as to which bearing is which. But for the intent of me explaining this problem to you, hopefully that makes sense.